G'day everyone, how are you going? Today is the 24th of March 2020, so if you're watching this sometime in the future, then I hope we all survive. We're kind of in the grips of coronavirus at the moment and school shutdowns are imminent. So these videos may become more and more important for those of you playing along at home and trying to follow through, in this case Methods 12, but other courses as well. Happy to do any videos you need. If you need something done, any of the courses in Year 11, Year 12, ATAR for WA, absolutely fine. I can do videos for anything that you need. Email me at chris.simpson@siwa.edu.au. I'll link that down in the description below. Please feel free to email me if you've got questions about things. I'll do my best to get a video up or to reply to you as soon as I possibly can. Today, where are we at today? Today we're at anti-differentiation. This is the next topic in our course. It's chapter 3 in our book. Don't know where it is in yours. Let's have a chat about differentiation first. Differentiation first. Remember, that's working out the gradient of a line, isn't it? We did differentiation by first principles, whole lot of working out the gradient of a line. Anti-differentiation is going back the other way. We're given the gradient function. We want to find the original function. Okay? You might see these words pop up as well, integral or integrate. Integrate is saying the same as anti-differentiate. Okay? Integrate is saying the same. So if that pops up, just think anti-differentiate, either word is fine. So let's do an example. If we're given the original function and we have something like this, what's this going to look like? Well, this is going to be a cubic, it's plus 5, so here's 5. It's going to do something like that. Give or take a little bit. So what's the gradient? Well, it's positive over here, it's going to come to 0 there, and then it's going to go back up that way into positive. That's fine, you know that. So we want to work out y dash, the derivative, dy dx, the rate of change of y with respect to x, derivative, or f dash x. Okay? And you should be able to see that and go, rightio, well, this guy, it's power out the front, lower the power by 1, and this one is really just a number, isn't it? That just moves the graph up and down. So that thing, we just drop it out. We don't worry about it because that's changing where the graph is. It's not changing the slope of the graph. So this should be all revision. Here we are, find 3x squared. But what if we were given the derivative, we didn't know what the original was, and we were asked to find the original? Well, we kind of reverse this rule. See how you said power out front, lower the power by 1. Well, if we do the opposite, if we raise that power by 1 and we divide by the new power, can you see how this 3 would be cancelled out by that one? So it's really just the reverse of this rule. Differentiate, power out front, lower the power by 1, integrate, raise the power by 1, and divide by the new power, and that will mean that that and that will then cancel out. And you can see that comes back to our x cubed. But we've got a problem. Remember this guy that dropped off? He moved it up and down, didn't he? Right? So we don't get him back. We don't get him back. We can't make it up. We can't say 10, 12, 3, 7. We can't make a guess. So we put what's called plus c on the end. And the c is showing us that we know the general shape of the graph, but we don't know where it is up and down that axis. So we just write plus c. And what we call that there, we would call an indefinite integral. An indefinite integral. Because I don't know the exact formula. I can give you the family of equations, but I don't know the exact formula. So this is an indefinite integral. If I was given a little bit of information about the original one, maybe I was given this point here at, I don't know, 2, whatever it's going to be. Let's work it out. 2 cubed is 8 plus 5, it would be 13. So if I was given that point there, I could then take that point from the original, put it in here and here, and solve for c. That would then become a definite integral because I know exactly where that one is. So at the moment it's an indefinite integral. There we go, look, we're flying along here. Here we go, let's do a couple of rules for different things. General cases. If the derivative is in this format, like what we had here, remember we raise the power by 1 and divide by the new power. So the original function will be raise the power by 1 and divide by the new power. That will get this part of it sorted. And then I've got to put a plus c on the end because I don't know where it is. Remember, that only moves it vertically. It doesn't change the shape and therefore doesn't change the gradient or the slope. So that's that style there. Let's look at this one. Y dash equals e to the x. Remember when we did exponential differentiation, the rule was, initially, on this one, the simple one, it really didn't change, did it? Right? Because you took the derivative of that and you moved it out the front. The derivative of x is just 1. So if you had this case right here, the answer is just e to the x. And then we've got to put our plus c on the end for the same reason. But I'm going to change this one a little bit. Instead of e to the x, I'm going to do this. I'm going to change this to e to the f of x. So I've got a function up top there. Now that could be 2x, it could be 4x squared, it could be anything. Now if I was to use this and differentiate it, I would go derivative of that out the front. So when I integrate it, I'm going to leave that exactly the same, but divide by the derivative of the power. So this will become still f of x up there, but I'll have to divide by the derivative of that function. Think that one through. If I had something, let's just do one quick here. So if I had y equals e to the x squared, and I was going to differentiate that, I'd get y dash equals derivative of this out front, I'd get 2x e to the x squared. Now if I want to integrate that to get back to here, can you see how I don't change that? Leave that exactly as is, but I divide by the derivative of that, which that will then mean that this part and this part cancel out, getting me back to that. So for your e to the f of x ones, it's leave this alone, leave all that alone, but divide by the derivative of the power. And don't forget your plus c on the end. Okay? All right, now let me just, you can rewind the video, I'll get rid of this. If you need to see that again, just rewind. Rightio, last one. Cos of x, the derivative is cos of x. So remember when we're differentiating sine, it goes sine, cos, negative sine, negative cos, back to sine. There's a cycle there, isn't there? Okay, so y dash equals cos of x. I think that's probably come from sine of x. I reckon that's come from sine of x. So I reckon our answer here will be sine of x. But depending on what you've got here, you've just got to remember that cycle that they go through and then reverse it if you need to, and wherever you need to move from and to, and of course your plus c on the end. So we've got our general standard integration idea here. We've got our e to the x integration idea, and we've got our trig integration idea. Okay, so we've got a couple of different things happening here. Now this topic will build, this is just the basics, it'll build into some fancy stuff. We'll use substitutions and need to rearrange things. It gets pretty tricky in this later on. So my tip is to make sure you've got the basics happening really well. If you struggle on these basics, in 3 or 4 weeks' time, you're really going to struggle. Okay? Make sure you've got this basic idea happening. What are we doing? Quick summary. If we get the original and we need to differentiate, fine. If we want to go back the other way, we've got to reverse our differentiation rules and add c on the end, plus c. Lots of people forget about it. You can't forget about it. You've got to remember it. Put it on your notes page right up the top in big red pen, plus c. In an exam, you might only lose 2 or 3 marks for it, but there's simple marks for writing plus c. Try not to forget about it. Hope this has helped. If you need more videos, you need any videos, please email me, chris.simpson@siwa.edu.au. Hope you have a good day. Catch you later, guys.